Alright. First of all, I want to say that I'm switching over to a 800 by 600 screen now. I was at a larger screen size, but I think it's just working too slow. So now 600 by 800, hopefully you can still see the schematic and everything. And the first lesson is going to be, well, it's still going to be on that part that I left off on. Sure. Okay. Let's see. Now, basically, we had this DC circuit. It has a resistor and it has a resistive load. And then what did we do then? Then we looked over here. There was a capacitor there. Down here, the capacitor shunted. You see that this is a shunt, by the way, just in case you didn't know. This is shunting to ground. Okay. Basically, it's like it's saying it's in parallel. And then in that case, parallel to the power source. Here we're in series to the power source with that capacitor. Now, these circuits here are very basic, and I wanted to do another page. Let's see, I have two pages. This second page here it's going to be pretty interesting because it involves an inductor. And inductors have some characteristics about them, and the other one had capacitors in it. But over here at page 2, I think we have, there I did put a capacitor in one of them. So, and two of them, I can show you about that later. So let's see, start page 2. Okay, now I'm going to add a new page. So I just come over here and let's see, new page, new project, analog or mix AD. Okay, that right there. It means that you have this is what I used here. Okay, this other one is PC Wizard. It does footprints and stuff, multi-layer circuit boards, I think, and all that kind of stuff. Programmable Logic Wizard, that's something else. A schematic, that's like if I just opened up PSPICE by itself. Right now I'm under Capture. That's going to include PSPICE stuff because this is a SPICE program right here. Let's see. So analog or mixed AD, and this is telling you that you can do a simulation here. This is what allows the simulator to work. So we'll name this. Well, this will be a new project here. This way I have a clean slate. We'll just name this. What should we name it? Basic 1, we'll call it. Okay, basic 1. As a matter of fact, basic 1 and how to what do you call it? How to set up. Okay. Well, okay. Create based upon existing project. We could create it upon this project, but I think what I would like to do is show you how to completely start all this. Sample. Oh, actually, it says create a blank project right there. Okay. Okay, now we have this project right here. This is our new project. This page is page 1 of the. See, basically it says, okay, here's the start page. Okay, this page right here is part of this, and this page is also part of this. Now, this is a new project. This page is part of the new project right there. See, so if you notice right here when we're looking at this, this is a file system of the project, all the files that are being, that it's generating and stuff like that. So right now we created this right here, this .dsn. Okay, then there's the schematic, the actual schematic, which right now is blank. It's over here though. Then we have the design, which has, excuse me, there's not much in it because it's blank right now. It's just blank. So, net group definition, that's not part. Library, alright, parts being used. Outputs. Okay, the outputs is what's going to be important for doing a simulation. It'll create the outputs, but if you were to give somebody the file, this file right here, this .dsn, and you had specific things you want to do with the with the probes and all, you had probe set and everything, then you would want to have an output file that you send with it, which will be generated out of this by the program. Okay, that'll be generated by the program. So if you were going to send this to somebody, you might want to send this to the outputs. And actually, resources, they'll have something there too. So .net is the file that has the probes and stuff. So once you send that to somebody with that .dsn, it'll the .net will generate on their computer whatever it needs to be when they start running things. Let's see, what else? Now this has been a while since I used this program here, and it's changed a lot, and they've added a lot to it. It works real good, possibly even better than the old stuff I had, the old student version back when they actually had one they called the student version from, I don't know, maybe 10 years ago or something. Now this thing has become really big, and it's pretty nice. It does some things that the other stuff didn't do, but they don't call it a student version now. They just call it a demo. So I'm getting used to this, or reused to it, and used to some of the new things while I'm doing this demonstration. So it's possible that something I say isn't accurate. And if I find out what the true answer is, then I'll just recorrect myself. Matter of fact, when I'm speaking, I'll probably say I think for things that I'm not really sure about. So the way that .net file that wasn't there yet, the way that .net file worked, I'm not totally sure exactly how it works, but it'll generate once you run a simulation, and I believe it has all the positions of the probes and stuff on it. So anyway, so we're on page 1. So first thing we're going to do today is we're going to build a well, it'll be a simple DC circuit for starting, because that's the simple thing. Easier to show. This way you get the understanding of where everything is. Now right now they have this bunch of buttons on the side here. Alright, some of these buttons, like right here, is very important. Place part. That's your components there that you're going to be placing down in the schematic, in schematic form. And right here, down here where the mouse is, libraries. Okay, that's all the different libraries they're giving you, or that you've connected the program with. And you can download more libraries off the internet. You know, there's different ways to do it. Matter of fact, this program right here being free, it actually does have some way of letting you. I did it one time. I think I downloaded. I don't know if I actually downloaded. I think I just viewed it, but it sent me to you know, different libraries that existed, and I found one that was the symbol for a speaker. Some had more parameters than others. They had the companies listed that came up with the symbols. I forget what one of them was, a famous company. Let's see. So this now here's something about the library. There's something a lot of people don't know, because when they lay down a schematic, they will have a problem running it in the simulator. It'll keep on coming up with errors and different messages. Some of those messages might have something to do with what part they selected, because some of these libraries aren't really meant for the simulator, and who knows who made them, you know, what they were originally for. It might have been for another program, and it worked here too, just for the schematic part, but not necessarily the simulator. It has to have a what's it called, something assigned to it. I forget what they call it. But here's the ones that work on the simulator. Analog, analog P right there. Matter of fact, we'll go through the parts list that analog has. If you notice down here where I have the mouse cursor, it has layout and it has PSPICE. That's telling you that it will work on the center. The PSPICE, it has the what's the word? I can't think of the word right now. But it has a certain set of parameters associated with it that the simulator needs to know. So all these in this library have that. Now some of them don't have the other symbol down here, layout. But the important thing right now is that we can run this on the simulator. Analog P is the same way. Let's see, one that is not that way, that has some of the same type of parts, is, what is it called? I think it's, yeah, discrete. See that? It's not showing that little, it's not showing the little icon down there, the little picture of the icon on any of these things. You run down the list real quick like that and see nothing. So, you know, they're good for the schematic drawing, but they ain't good for simulator. Source. Now the source, okay, it has the, okay, we got different sources. Now we're going to look for a DC, okay, right, well, where's the DC one? There, right there. Okay, there's the AC one. There's the DC one. There's also another signal one that you can make it an AC. DC, AC. Okay. Yeah, they got different shapes. Okay. So that's one we're going to be using here in a second. I just want to show you too that over here, place the part. You got that over here too. Place right there. See, you got all that stuff right there, and you might even have a few more things. I don't know. There's a few things that weren't on the button. Or this bunch of buttons here. Let's see. DC. All right. So now once we have this, we double click it. See, there's nothing there right now, and it's good for the simulator. And if we double click it, and then we just click one time, and we can click more times if we want more voltage sources. But now you can go up here and hit the arrow, and it'll be off. But or to get this off of that you're done using it, or you can just say in mode. That was a right mouse click and then in mode. Okay, also escape. And the keyboard shortcuts are probably the best to use really if you're going to be doing this a lot. There. Okay. Now, we always need a ground anytime we're going to be running a simulator. And we always need a ground. So, where are we at here? We got source. Well, first let's just finish designing that. Okay, this is going to be a pure resistive circuit here. Okay, just for simplicity right now. Analog. Resistor. There, well, you just click there and hit R on the keyboard and it'll take you there. There's a variable resistor. See that? It's got the little arrow running through it. That's not op amp. This is a resistor at a 45-degree angle, which can help the drawing look better with certain types of resistor systems. Just to show that it's a system. Where's the regular resistor? Jeez. R. Oh, right there. I was one. Huh. Why did it show me a variable one? Or maybe, I don't know. Anyway, double click that. Place. By clicking and then escape. Okay. Now we have. You know what? How about we place another one? And it'll be the load one. Matter of fact, if you want to rotate it, you just hit R on the keyboard. See? Alright, now we come over here. We got the ground. The ground symbol. Now they have a button for that over here. It's probably the easiest thing to do. It has one with a number 0 right there. Okay? That one with the number, that ground with the number 0 is the only ground that you need to have one there for PSPICE to be able to simulate stuff. Okay, otherwise it'll just throw errors at you. We have a ground there and a ground there and escape. Okay, now let's zoom in on. Well, you know what? Yeah, let's zoom in on this a little bit. Let's move this over here. By the way, I zoomed by doing when I have nothing selected, a right mouse click like that, and drag it, and then let go, and that zooms in on it. So you can zoom in on just this voltage source right here with the resistor. So anyway, seems to kind of remember where you zoomed from too a little bit. Okay, so now I have this right here, this button up here, drag to connect. I usually have that shut off, and then I try to have snap to grid on. I should have started out with it on, and then now I'm going to start placing the wires. Now the way this thing works, matter of fact, first I want to show you something. Okay, sometimes this thing's a little bit hard to aim with. Put it right there. Okay. Okay, I hit Control when I did that. I clicked on something, and then I clicked on, or then I pushed Control and clicked on another thing. And I can say connect. Not connect to bus, but just connect. Okay, and it automatically connects it. See, I can do that. So if you're having trouble aiming, then you might want to do that. Auto connect multi-points, that's another option. You can, that one there is kind of neat. How does that work though? I forget. Connect. No. I forget how that one works. Anyway. Oh, no, it did something. Anyway, well, that's one way. I don't really use that way too much. This right here, this is another connection tool. This one here, you can see red dots. And see, I have that selected there. Oh, and if you want to kind of shortcut things a little, you can actually do, like, sometimes I do this. And then, oh, come on. In wire. And the wire. See what I mean? I don't know why I make it so there. Okay, right here. Fit it and you can connect. Alright, right there. Delete that wire that goes over top of it. Let's first test it. There, okay, there. This is delete this wire. It goes over top of it. Okay, now we should be good. We try to give it a little check out. Let me just redo that. I tell you, that's one thing I don't. It seemed like it was easier to connect wires with the old one. I don't know, maybe maybe there's a little trick to it I'm not knowing. Well, why can't I connect to that? See? This is irritating. There. Alright. Okay, I think everything's connected. Imagine if I had a big schematic to do. How much time it would take just to connect wires. There. Alright, voltage source, whatever. Okay, now they rename this one here. You gotta be careful what things you rename. But RL. Just to RL. And maybe it's 8 ohms. The speaker or something. It's purely resistive. This one here will just leave 1K. This one here, we're going to have to, okay, I want to show you the part editor. If we want to edit the part right there, or the properties of the part. Okay. See, it pulls up this, the properties of the part. It pulls up this thing right here, property editor. Now, this is that component's properties. And some of these things are highlighted, and we won't have to worry about some. For the voltage source, the main thing is that you give it voltage. So, we could call it 10 volts just to have a nice number. Enter, and yeah, that's good enough. Hold on. Oh, yes, okay. Yeah. Okay, now we just, they have other tabs down here, okay? Then I'm not going to explain all that stuff. I don't even know what all is. Page basic, page. Alright. Okay, now that we have this, we can run a simulation. When we do so, now we have probes up here. Okay, these are okay. This is a voltage probe. This is a current probe. This is a power probe, and this right here is difference. Okay, voltage differences. So you can see the difference between, you know, one node and another. So we could look at the difference between here and here if we wanted to, but we're not going to worry about that right now. We got voltage. It really, it'd probably be more like for like a push-pull amplifier or something you wanted. Well, maybe not push-pull, but like certain types of filters that cancel things out. That's where you might want to see the difference. Okay, so right now I just click the voltage probe, and we know that's 10 volts. But what about this? So I have to put it on the wire. And that's one thing that sometimes it doesn't want to take real well. But there you go, it's on the wire. I can even take a look at the current right there, but I have to put it on the end of the component like that. See the R? I have to put it on that end right there. It won't go anywhere else. It won't. Current marker will be ignored unless connected to a pin. Okay, see? So it has to be connected to a pin. And this voltage, try to do it out here. It says voltage marker will be ignored unless connected to a wire, bus, or pin. So those are options there. And that's good. Okay. Now we probably know some things about this type of circuit here. And I don't need to explain it because the simulator is going to explain it here. First, you need to hit new simulation profile. Okay? Or hold on. It's not what you need to hit. Oh yeah, okay. Let me just say new simulation. Basic 1. Okay. Inherit from none. Create. Okay, now you see the buttons here are lit up right here. And also these are too. Okay. This is what's going to calculate voltage and current and all. It'll show it differently. Alright. So, let me just go ahead and put these. I should have done that first. This is telling the simulator what to probe. Those other things just tell me for schematic purposes. Matter of fact, I can show you that it won't show nothing on the like actually you can just hit that and they'll come up. This is edit simulation profile. Okay, that's view the results. Let's just do a little run real quick. Okay. So it's telling us some things, so we don't really need to probe that. Down below, it did bring up the simulator right there. Okay. But there's nothing drawn on the curve because nothing's. I'm not telling it to do anything. So now I'm going to, and I can take these off if I wanted to. Just look at the volts, for instance. The volts, you can see how voltage dropped down right here. Now we're 79 at about 80 millivolts. Stuff like that. By the way, in these components, you can double click it and get to that component editor or whatever it's called. Basic value, power. They have different things that have real life scenarios too. Well, I guess just characteristics that are used in environmental things, like power dissipation or power value, different things like that. looking for, okay, right there. RL2, there's where I renamed it. That's called part reference. Alright. Flat. Just that some of these things I can't remember what they mean. If you want to find out what they mean, though, there's help. And the help is very let's see, but which one was it though? I think it's just this one. Right. There it is. Go back here. Okay. Their help is pretty good. See, they have this little pane right here. Yeah, you can figure all this out, but there's one, and I should have marked it or something, that had what all these different things mean. So you don't have to always look it up on the internet. But I'm not going to sit here and try to search through that right now. Anyway, you get the idea. Right now we got what we need, and simulator. Okay, so right now we got the simulator up, but nothing has been probed. We can stick a probe on here. We'll stick a voltage probe. How about right here, like we did last time? And okay, and see how I plotted it already. Current. Put the current on the node, on the pin. Okay, now, so we got current right there in red, and see the color of the markers, right? It picks out the colors for you. Sometimes values will be shown negative, by the way, on this, like it is right here. It's actually showing a negative current. Okay, now we want to take a look at the, right now it's running under these credentials here. Come on, where did it? Edit the profile. Oh, I had it over it. How did I do that? Okay. Alright, well, you know what, let's just do this. New one. Okay. That's one thing, you gotta look for these buttons at the bottom, because sometimes, for some reason, this program sometimes will launch something behind the window you're working on. I don't know why it does that. Let's see. Start saving data. Okay. Now we're in, right now, the analysis tab. Okay, there's general. General is probably what it needs to be already. Well, it is for our purpose. You usually want to set up the analysis, though. Here's the probe window, display probe window, blah, blah, blah. A lot of this other stuff we don't really, options, let's see, gate level simulation. See, now those are more advanced things you'd be dealing with certain types of transistors and stuff like that. See, it even tells you the MOSFET, because it has a gate. Relative accuracy, blah, blah, blah. We don't need to know all that. But I mean, if you were really designing something that had transistors and you wanted to be really accurate and realistic about things, you would want to set some of this stuff. I mean, there's stuff like that that's set all over the place within each component on the simulation profile and all that. Right now we have the options. We have general settings. You can have Monte Carlo worst case scenarios. where the circuit is at its maxes and ready to burn up and stuff like that. Those are interesting there. Those can be real useful and important in a design because thermodynamics is important in a final design. Otherwise, you might make something that burns up, you know. Or everything will be overbuilt. And you spend a lot of money on overbuilding, possibly. And when you could have just run and actually, OrCAD has a program too, by the way, that does thermodynamics. It does look like it does it pretty well. I don't have it though, but I've seen the videos about it that they show on their website. They're pretty neat, three-dimensional and everything. Parametric sweep. We don't need to worry about that. Temperature. I mean, some of these things we might want to do sweeps and stuff like that. But we don't want to do that right now. Okay, restart it. Okay. Anyway, so we're just gonna stick to the general stuff. Run the time. I mean, after all, it's a DC circuit, real basic, all purely resistive. Run time. This tells you how long the simulator is gonna run. You know, how long it's gonna monitor voltage going through. In this case, 1,000 nanoseconds is more than we really need. Try to keep things working well. 1 nanosecond, how about that? Okay, then we have start saving data after a certain amount of time. Well, 0 seconds. We want to look at it immediately. Okay, of course this is purely DC with a battery for a voltage source, so you know, you're not going to see anything special up close. Transit options, maximum. Okay, now this has to do with the precision, like the resolution of the graph. Excuse me, the resolution of the graph. You can go up to, well, I'm not really sure how precise you can get, but I know 40F, like this. 40F seconds is really precise, but it takes a long time to process. You're going to want to have your runtime real short, or if you don't, they will warn you. They'll put up a dialog box that warns you. And matter of fact, output file options. Okay, matter of fact, in Resonate, I don't know what that is. I'm going to just go ahead and use 40F, and I'm going to use, just so that it don't take all day, 0.001 nanoseconds. And I'm going to say OK. Now I'm going to rerun this. Oh, it's not going to tell me the warning because it's such a short time that it's going to run. Darn it. I wanted to show you that warning. Maybe I should just do 1 nanosecond. Okay. Let's see, what's it going to... No, it did it anyway. Darn it. Okay. Anyway, it gives you some kind of warning sometimes if it's going to be a real, you know, a lot of processing time. And when it does that warning, you know, it gives you some options. I think 3 different options. The 3 options, one of them has to do with it. It'll look at we'll go to the sim there. It'll look at the sim in sections. It'll say, okay, this section we're going to show detail on. This one here, I think it just shows up as straight lines. I think I've seen that before on the old one. Until you scroll over to it or whatever. So you just got to keep that in mind. That's not a problem with your circuit necessarily. That's just them saving you processing power. There's another one that will do the plots a little wider, I think, something like that. Right now, though, we got this, and you can see where the probe was, right here, and the current one right there, and we see what these levels are. Over here, we can't use the right mouse click to do zooming, as far as I know. Can't zoom any further. So you can hit it like that. Alright. Where are we at? Oh, we're already pretty close in. Okay, so we're you know, there's the other one. 80 millivolts. And what does it say over here? Oh, notice it's slightly below 80 millivolts. Okay. Over here, we have slightly below it. I mean, I've seen times though where it was below it more than it said over here, but I think it was measuring something real life. I don't know. I think I did set something to show some type of a loss. Performance analysis. FFT. You know, there's just different things that you can use. Not going to worry about some of this stuff though. We'll worry about this later as the time comes. Evaluate measurements. That's something that probably won't use too much on simple things, but it applies different functions to that. This is your list though. This is what's important right here. Your list of values, or of probe points. Okay, things that you're probing for, and you know, stuff like that. You can deselect this, see what's what. Okay, we say analog time. Okay, there's all our voltages. There's all our currents instead. Power. We don't need to know all that right now. Right now, I got the probe set right down here. Cancel. Right there. And you know, you can mark data points and stuff, label things, add a trace. You can add another trace that looks like that window right there. Actually, works the same way as the other one I showed you. Down here we have our plot. Down at the bottom here, you can double click something and it'll come up that way. What was I going to do? I was going to show you something here. Alright, there we go. Okay. See, now it's going to follow things, and you can see down below all the, you know, things that it is. And you can even see how it's dotted right here around the marker symbol. You can write that with a right mouse click. So I have two different options on. You know, I can mark with the left and with the right. So this one's marked with right. This is marked with left, and it shows up down here what I'm marking. I can you know, mark that one instead, but I do it like that, you know, or switch it around. And you know, now if this was a sine wave, you'll see some of these values moving a lot. And also for waves and stuff, they have, you can go to your peak value of something. Here's DC, so there's all peak. Cursor slope, you know, stuff like that, just different search command. about that. Yeah, different things. Okay. So that is... Oh, one more thing before I end the lesson. Look over here. I should have told you, right when you hit that button, it is going to make the .NET. Okay. And that makes this stuff down here, including that. This is the one, though, that you can actually find. It's a file that you can find and send to somebody. Matter of fact, and I'll show you where they normally store these files. You can go to ABCD, OrCAD. What? Why isn't it? And then OrCAD Lite, 16.6 Lite, because that's what this is. And then Tools. And it's for some reason they like putting it in Tools. That's what it was default at when I loaded the program anyway. And I probably said, since it's generating different files and stuff, it might be a good idea to just let it go where they have it going on default. Maybe. I don't know. I don't know if the files will follow, the original file or what. So anyway, there's Capture right here. We're in Capture. Okay. There it is. There's... Whoa. Analog Learn 1. Is that it? I think that might be it. What do we have here? Schematic 1 Net. Schematic 1. Okay, type. Wait a minute, where did it say it put it? I think it's in the folder that it makes. Basic 1 and how to set up PSPICE files. Schematic, yeah, Schematic 1. That's right, okay. It's in the folder it creates. Okay, right there we have the Netlist file. Boom, right there. And this is simulator settings. I guess you would want to send that to somebody too, really. That should be the button I pushed right there, that is simulation profile. Then probe document, output. See, I think these get automatically created, but I don't know. See, I don't really know what you need to send exactly, to get the entire thing to somebody. I guess you could be on the safe side and just send all this. Send the whole folder. Yeah, probably send the whole folder there with, or that whole folder, with the file that has that same name over here, the .dns or whatever, wherever it went. Yeah. Oh. It's not it. Oh, the OPJ file. I don't know. I still gotta figure that out. I'm supposed to be able to use this cloud program, and can't seem to get it to work. It's something Microsoft's behalf. See, in the start page they give you this cloud option. I don't see, I can't get nothing. I can't get nothing. Anyway, whatever. The thing is, you gotta use the actual Azure program from Microsoft. This is just the Azure connector here. Okay. Alright, so I guess that's good enough for now. I'm gonna go ahead and save. And get out of the program. Save changes. Yeah, we'll just say yes to all. Alright. Was thinking about going into a lesson real quick on resistors and DC. But I guess basically here I got just a paint program up so I can draw something for you real quick. Haven't even hardly used this new paint program. Let's see. Okay, I'm gonna tell you Ohms Law real quick. This is Ohms Law. Okay, some people draw this as a triangle. Same thing. And it says E I R. In the form of ohms. I is current and E is voltage. And actually, a lot of newer books say voltage now. They just have to be that's the new way. Anyway, what you do is you can say, if you want to find the V, then you have to have I and R. Okay? If you want to find the I, well, if you want to find the I, then you have to have V and R. And what it means is V equals I times R, or I equals V over R, or R equals V over I. It makes it real easy. The part you want, you cover up with your thumb. Now, let's see. Kind of using a book to guide me with this. That's why I keep on looking over. I don't know. Basically, if you have resistor and let's say you had voltage source and you had resistors, right? There's your grounds, and you'll node, and you had another resistor, and they're in parallel. What will happen here? Where's the calculator? Is if you want to find out what the resistance is, let's say this is let's say 16 ohms, and this one is, let's say, 32 ohms. Okay, when resistors are in parallel, you could say 1 over R1 plus 1 over R2, and if there's more, 1 over however, whatever else is over there. Whoops. And for number, okay. So, since we have 2, we're using this much. So you could say, 1 over 1 over 16 plus 1, oops, yes, 1 over 32, was it? Yeah, 32. Okay, equals. So that's what your total resistance is right there. It is 10.6. Yeah. 10.6 ohms. Okay. So that is, that's a little calculation you might want to keep in mind. I mean, because you don't want to always use PSPICE for figuring out everything. It might take longer that way. What I usually do is I draw things out by hand first, usually, and then in the book, by the way, that I'm using for reference right now, I'm not too impressed with it, but all my books wound up getting ruined. Water came through the basement, I guess. This is the book, and they have different charts in here and stuff, and things like that. It's an instructional book, I guess. It's nothing they would use in college, but it's good enough for me to reference out of in case, my mind drifts a lot or something, I guess. Alright, so I guess this is a session that comes to the end here, and that'll be all for the lesson right now. Alright.